Hi everyone, let's talk about solving the Pell linear recurrence. We're going to have a sequence of integers that are defined as follows. The first one is 0, so the 0th index gives p0 equals to 0, then p1 equals to 1, and in general for n greater than or equal to 2, pn is equal to 2 times pn minus 1 plus pn minus 2. So as you can see, the first few integers in this sequence are 0, 1, 2, 5, 12, 29, 70, 169, 408, and it keeps growing like that. As you can tell, it grows quite quickly. We've reached 3 digits in no time. So to solve this, we're going to use the theory of linear recurrences, and the first step is to define the characteristic polynomial g of x, which in this case is equal to x squared minus 2x minus 1. And we got that from the recurrence relation. Then what we do is that we find the roots. And by the quadratic formula, the roots are 2 plus minus square root of 4 plus 4 divided by 2, and that's simply equal to 1 plus minus square root of 2. So notice that they're distinct. And that is going to allow us to use a simple case of the theory of linear recurrences. We're going to let alpha equal to 1 plus square root of 2 and beta equal to the other root, which is 1 minus square root of 2. Now, by the theory of linear recurrences, there exists a C1 and a C2 in the real numbers, such that for all integers n greater than or equal to 0, Pn, the nth Pell number, is equal to C1 alpha to the n plus C2 beta to the n. This is what the theorem tells us. So it's just a matter of determining what C1 is and what C2 is, and then we're done. So what we'll do is that we'll work on P0 and P1, because we know that P0 equals to 0 and P1 equals to 1. And by this theorem, we know that P0 equals to C1 plus C2, and P1 equals to C1 alpha plus C2 beta. So let's solve this system of equations for C1 and C2. We get C2 is equal to negative C1, and we can substitute it in here to get 1 equals to C1 alpha minus C1 beta, and that means C1 is equal to 1 over alpha minus beta, which is equal to 1 over 1 plus square root of 2 minus 1 minus square root of 2, which is just equal to 1 over 2 square root of 2. So that tells us that C2 is equal to negative 1 over 2 square root of 2. And now we can just plug that into this formula over here. And we find that Pn in general for n greater than or equal to 0 is equal to alpha to the n minus beta to the n over 2 square root of 2. And that's equal to 1 plus square root of 2 to the power of n minus 1 minus square root of 2 to the power of n divided by 2 square root of 2. And that is the formula for the nth Pell number. I know it looks like it shouldn't even output integers, but in general there are so many cancellations that it does output integers. In fact, it outputs the nth Pell number for if you substitute in n. Thanks for watching, and I'll see you next time.